can give any name to the array. There are some rules, but basically we shouldn't use any predefined function names, and we can give any name to the array, and then we use a square bracket. Now it's not necessary to specify the size of array every time, but we generally do. So this is the basic syntax. First define the type of the data elements you want in the array, then the array name, and then the size of the array, or square brackets you have to put. That's compulsory. Okay, so let's see some of the different types we can initialize an array with. First is we have simply initialized an array of size 5, and we have also defined the elements in an array. So this is the normal syntax. Here the data type is an integer. We have defined the name of the array as numbers. We have used the square bracket and defined its size as 5. Now we can simply define it like this. In the third example we have seen, we have only defined the array and not allocated any element to it. This is a kind of definition also, but here we have also initialized the elements along with the definition. So whenever we initialize, these will be the initial 5 elements of our array. Okay. Now in the second example, we haven't specified the size, but we have specified the elements. So the array will be of size 5 as we have defined the size of the elements. Okay. In the third one, we have not defined the elements. We have only defined the array along with its size. So initially there will be no elements. Random elements will be allocated to their position. Random values will be allocated to the element position. But we have to define it, so we can use a loop simply, like here. As I said earlier, that whenever we are using an array, we have to use it by index. So we simply running loop from 0 to n minus 1. Okay, so this is important, that as we are starting from 0, so if we have 5 elements in an array, the last index will not be 5, it will be 4, because we are starting from 0. So this should be kept in mind always whenever we are assigning elements. So we start from 0, we go on till 4. So number 0 will be 0 plus 1, so 1. And similarly, we will get the array 1, 2, 3, 4, and 5. Now there is another way you can initialize. When you are initializing it partially, means you are not allocating each and every element, you are only allocating partial elements, and later on you can allocate other elements which whatever value you want. And lastly, we can initialize the array with 0. If we have to just compare the elements and then put some elements in it later, we can initialize the array with 0, so all the elements will be initialized to 0. So is it clear initialization to everyone? Okay. So now we'll see some more operations. First is accessing the element. Now we access the elements in array using its index. So here you can see an example of it. We have an array 1, 2, 3, 4, 5. Now we want the first element in an array. The indexing starts from 0. So we have put number 0. The first element will contains the 0th index element of the array numbers, which is 1. Next is updating an element in the array. Now, if you want to modify the arrays, like here, the example 1, 2, 3, 4, and 5 we have, but we want to change the element at the second index to 10. So we have simply assigned the value of 10 to the second index of the array. Okay. So in the updated array, we can just see that the element 3, which was at the second index in the initial array, is being replaced by the element 10 in the updated array. Okay, so you can simply assign it by the index. So you should, indexing is really important. You should correctly define the index, and then you can easily update the elements. Next is traversing. Now traversing simply means we use for loop. So we are just going on each and every element. We are touching each and every element. Okay, so here we have defined the array of table of 2. So we just define a for loop, and we are printing each and every element. So we start from the 0th index, go till the n minus 1th index, which is the 9th index, and we are printing all the elements. So the complete array is being printed. These are basic operations, but to get an idea, we are just overlooking over them. Now this is important, size of an array. The size of an array is calculated using the size of operator. Okay. So size of operator gives us the size of the array, but if we want to find the size of specific data type, we can use the formula as I have shown here. Size of whatever the array we have given the name upon the size of the index which we are putting. So it will basically give the size of whatever data type we have used. Like here we have used integer, and the name of the array is numbers. So here to find the array size, we have used size of operator, size of the array name, which is numbers, divided by the size of the zeroth index of a number. We can give any index, it will basically just divide it by the size of it. So here the output will be 4 because the size of an integer is 4. But there is one complexity with the size of operator. Whenever we are using functions, as we'll move on, we'll see in questions. To solve questions, we most of the time define function outside the main function, and we pass whatever the values like an array, etc., into it. Now, we can say one of the problem with arrays is that if we are using size of operator, we cannot use that in a function. So whenever we pass an array to a function, we have to explicitly pass its size along with the array parameter. We can't simply just pass the array in a function and later on use the size of function in the array to find out its size. So that's a complexity. Whenever we have to like pass an array to a function, we should pass the size of an array explicitly along with the array. Okay, so this should be kept in mind. We will see in when we see vectors that how it overcomes this. That's why vectors are more used over arrays. We'll see that later. So this much is clear to everyone. If you have any doubts, you can ask in the chat. Okay. Okay. So we move on. Now it is not necessary that an array is only defined as a single-sized one-dimensional array. Array can be seen of as a matrix as well. So here comes the concept of multi-dimensional arrays, right? Yeah, someone raised hand. If you have any doubt.
Yeah, actually, size of array divided by size of the index
Yeah,
should give the number of elements in it, right?
yeah, that's what we want to find. We have defined the size of an array as 5. Now, if we want to use it later, like we are running a loop, we want to find what is the size of the array for defining the loop from 0 to what size we want, from 0 to 4 we want. So for that, we need the size 5. But if you use this formula that we have shown here in a function, when you have passed the array in the function and you use the formula, it will not give you the correct size. It will not give you the output 5. It will give you some random output, maybe 4 or maybe 0.
Okay.
Okay. Is it clear?
Yeah.
Okay. So multidimensional arrays, you can see it as a matrix. We can define matrix of any size. We all have studied matrix. So similarly, we'll see two kind of multidimensional arrays. It's not necessary that these two have to be used. We can define any size arrays. So this is the general syntax of a 2D array. Okay, where we have rows and columns, just like we make a box of it. We can relate it with a matrix. We have n, which is simply the number of rows in our 2D array, and m, which is the number of columns. Okay, so this is the syntax similar to it. The data type of the element, the name of the array. Then we use two square brackets as we have to define the row as well as column. Okay, so we define it n and m, which is the number of rows and number of columns. So here's an example. We have defined an integer array of size 4 cross 4. So we are defining a 4 cross 4 matrix. We can just think of it like that. Okay. This is simply assigning the elements. As we have 2D array, we have to use two for loops to assign the elements, ith row and jth column. So firstly, we are assigning the element to 0th row and 0th column, then 0th row first column, and so on. We will keep on assigning the elements. So this is how a 2D array will look after definition. Here are the rows and here are the columns. Similarly, we can use three-dimensional arrays as well. Here we have to define three parameters now that we are defining the three dimensions. Along with rows and columns, you also have to define about the depth of it. The syntax is same: data type, array name, and then the depth, number of rows, and number of columns. So similarly, we have defined over here array 333 is our depth, number of rows, and number of columns. We have assigned them using three for loops now that we have row, column, as well as depth. So it will give in layers, like we are using 3D. So it will basically be a collection of 2D arrays. A 2D array is a collection of many 1D arrays, as we can see over here. This is a 1D array, this is a 1D array, this is a 1D array. Okay, similarly, a 3D array is a collection of multiple 2D arrays. Like this could be a single 2D array, this can be a single 2D array. So as we move in dimensions, these are basically a collection of whatever the previous dimension was. So is it clear to everyone? Okay, okay. Let's move. So now we come to vectors. Now, why we need vectors when we have arrays? What do you think? What are the uh, reasons we will need array?
Size is fixed of array.
Yeah. Yes, dynamic nature. What else do you think? Yeah, these two are the main reasons, and another reason which we you will explore is that we'll get a lot of STL functions when we are using vectors. There are many member functions of it which we can use to ease our coding. Okay, we'll see some of them over here, and else you can read as you proceed in your coding journey. Okay, so vector is a dynamic array. Now what does it mean? It simply means that we don't need to define the size of it, or we don't need to keep the size of it fixed to a particular value. We can anytime increase the size of a vector, and that gives us the advantage whenever we don't know about the size of the data we are using or whatever thing that we have to define. Okay, so let's see how we declare a vector. The syntax is, first you have to define vector. Okay, you have to write the vector, and then you have to use angular brackets like this and define the type of elements: integer, strings, char, etc. Okay, followed by the name of the vector. For example, we can see here two different types of initializations. Here we have defined the word vector. The data type we want is integer. Then we have given the vector name, and then followed, there are two types. Now we can define the size and value. So what it will do over here is create a vector of size 5 initialized with a value 0. Okay, so each and every element of the vector will be assigned a value 0 if we are using this syntax. But if you want to assign different values to every element, you can use this kind of syntax. Either you do vector int v is equal to and then assign the elements as we have done in arrays, or you can do this syntax vector int v, then use circular brackets, and inside it you put all the elements like we did in arrays. So you can use any of these types depending on what's your need. Okay, let's see some more operations. First is the size. Now as we saw the size of operator in array, in vector the member function that we use to find the size is v dot size. So it will simply return the size of an array. And another disadvantage that we saw is that whenever we use or pass arrays in member functions, we have to explicitly or differently pass the size of array along with it. But in vector is not necessary. You will simply pass the vector into the function, and inside the function, if you use v dot size, it will accurately give you the size of the vector. So this is the advantage of using vector over an integer whenever you're passing it in a function. Okay, now how do we access the element? One of the ways, it is similar to an array, so you can simply use the index. It is also zero index. It is not a different indexing. The zero indexing is similar over here. Another way you can access the element is using the dot add function. So you will simply use like we can see over here, the vector name is v. So we have used dot add function v dot add, and we have defined the index at which we want. So v dot add at the second index. So it will simply return the character f. And above we have used the array type access, where we are accessing the third index, which is character d. Now updating is similar to what we have seen in accessing. Either we can do it by simply accessing the index as we did, or we can use the add function. Let's see insert. We have two different types and some syntax over here. So first syntax is, we are defining the position at which we have to insert the element and what value we have to insert in it. Okay, so here we have defined a vector which is 1 2 4 and 5. Now we want to insert an element at begin plus 2 index. Now v dot begin is always 0. Okay, we are using a 0 indexed, so it's always 0. So 0 plus 2, so we have to put element at the second index, and the value of it is 3. So you can see over here at the second index, the element 3 has appeared. So it will simply shift the other elements forward and put the element which we are adding at the position we want it to be added. Okay. So this is a syntax where you want to just insert a single element at a particular position. Okay. Now, if you want to insert multiple copies of that element, what would you do? In that case, we can use this syntax where we are, along with position and value, also defining the number of times we have to repeat the element. Okay. So here the syntax is similar. V dot begin plus one. We are inserting at the first index. We have to like insert it multiple times. So how many times we want to insert? We define at the second position, which is we want to insert it 3 times, and then the index at which we want to insert, which is the second index. So simply at the second index, we have inserted 3 2s, and the other elements have been shifted forward. Okay. Another syntax is that we can define the first and last position and insert a range of elements. Okay. So what is the first is simply the first element which is to be inserted, the position of the first element. But this has to be paid attention that the last is the iterator of the element one place before the last element of our range. Like if you want the range to be till 5 elements, we will define it till 4. Okay, here's an example by which you will understand. uh, I will give just a quick idea of L dot begin and L dot end. Simply, L dot begin is defining the start of the vector, so it is pointing to 0. Okay, and L dot end is the end, which is our size. So simply, we have to insert the element at v dot begin plus 3, that is the third index. Okay, and we are defining the L dot begin and L dot end. So it is to be inserted right from the beginning up to the end. So the element 4 5 has to be inserted at the third index. Okay, so here only 2 index are present. So simply it will be inserted at the last. So we can just see that 4 and 5 elements have been inserted over here. Anyone has any doubt till now in insertion? Have you understood this syntax? The three that I've just spoken about? If you have any doubt, ask it in the chat, okay? Or simply you can open your mic or raise hand. Okay, another way you can add an element is by using pushback function. Now here you can't explicitly define the position of it, but simply add an element to the end of a vector. As we have said, it is like a bookshelf. So in a bookshelf, it's like simply adding a book to whatever space you have at the end. So the syntax is simple: v dot pushback, and in circular brackets you will give the value that you want to insert. Okay, like we have inserted the character z over here in the vector v. So the resulting vector is ACFD, and then at last the element z has been inserted. Okay. Now traversing is similar to what we did in array. Simply we will use a for loop, and as we have indexing, so we will simply traverse the vector using its index. Okay, that's not different in it. Okay, let's see deleting an element. So we use the erase function to delete an element in a vector. Now it can be two syntax. First is v dot erase, and we are defining the position. Okay. So whenever we are defining the position, we are erasing a single element over here. So you just have to define the index of the element you want to erase, and it will erase the element at that index. But if you want to erase the range of elements, you will define it using the first and last. You will define the complete range. Okay. The first and last definition is similar to what we have seen above. First will be the iterator to the first element in the range we want to delete, and last will be the iterator pointing to the element previous to the last element that we want to delete. Okay, so the range should be defined simply, and the deletion will be occurring in a range of elements, not a single element will be deleted over here. Now, similar to pushback, another function is there, popback, which will simply remove the last element. So we have used here popback function. We don't have to define the value because it is simply removing the last element. So whatever will be the last element, it will simply remove it. Okay. So this is the syntax v dot popback, and we don't have to give it any element because it will simply remove the last element of the vector. Okay. Till now it's clear. Okay. Okay. Now we move on to sorting. How many of you know about sorting? Have you seen any sorting algorithms earlier? Yeah, speak up, sir. Are you?
I've learned search sort, selection. No, sorry, selection sort, bubble sort, um, insertion sort.
Okay, okay. So we'll also be touching upon these sorting techniques. Now there are many sorting techniques, but the thing is, why do you think sorting is important? Generalized, you can think of it in a generalized way. Why sorting is important? So yes, to arrange the data, order data, yes. So let's quickly see why it is important. Here I have defined, given three reasons of it. First is the efficient data retrieval. Now, whenever we want to retrieve data, if the data is sorted, it's simply arranged in a manner that we can understand where we can find the element. Now, if we have been given elements from 1 to 100 arranged randomly, it will be a really hard task to find any elements from it. But if we simply sort them, we can simply like access them easily because we know how they have been sorted. So the max element will be at this position, min element will be at that position, and the comparison between the elements also becomes easier. Next is data analysis and decision making. Now, if the data is sorted, what it simply means is that the similar kind of data is close to each other. So if similar kind of data is close to each other, we can easily group them into a certain kind of data. If we want to apply certain functions, we can define the range of it. So the operation is successfully executed in that kind of elements. So in case of data analysis, also sorting is important. And in cases of algorithmic efficiencies, like in the next lecture, we are going to see the searching techniques in which we will learn about the binary search. Okay. So in binary search, it is essential to sort before we apply binary search. So there are a lot of algorithms where sorting is needed. So the efficiency of a algorithm is also increased when we sort the elements. Okay. Now there are several sorting techniques, like some of you have told. So we'll see the basic of it. There are more sorting techniques which we will maybe see later because we have not touched upon recursion and pointers and etc. that we will need. So the three most important sorting techniques will be covered today. Okay, let's move the first technique. That is the selection sort. Now, by the word selection, you would understand what does it mean. Okay, it is a comparison-based sorting algorithm. Every sorting algorithm, you will see one thing. I don't know if you know of it. Do you know about pointer? Why it is used? Like not a particular pointers, but we simply use pointers to point to an element, to a position. Do you have an idea of pointers?
It gives the address of the next instruction.
Yeah, yeah. Okay, okay. So you have an idea of it. So we'll see use here pointers as well as min and max function. Basically, min and max function give you the minimum and maximum element by comparing two elements. Okay. So let's see selection sort. In selection sort, what we do is that we repeatedly sort an element by selecting it. Like we can select the smallest element or the largest element from the unsorted position and swap it with the unsorted with the first element or maybe the unsorted element. Okay. So this process we have to do repetitively until the complete array is sorted. Let's see it stepwise. Firstly, we will find the smallest element. As we are using smallest sort over here, we can also do it using the largest sort, but we'll first see it for smallest. Okay. We will find the smallest element in the array and swap it with the first element. Now, why first? Because we want to sort in an ascending order. So we have to put the smallest element at its correct position first. So what is its correct position is the the first index. So we are swapping the smallest element with the element at the first index. So this will put a single element which is the smallest element at its correct position. Now after that, we will find the next smallest element. We will exclude the first index. Now that the element at the first index has found its correct position, we'll exclude it. Okay. The next smallest element will be found now, and then it will be swapped with the second element. Because the first element has found its place, the second smallest will go at the second index, which is index number 1. Okay. So we keep on repeating this until the complete array is sorted. So here's a example of it. Here we can see the elements, the array 64, 25, 12, 22, and 11. So first we'll find the minimum element from the array, which is 11. Okay. So we will simply use a pointer which will point to 11, and the current element which will be the first index. In our case, because till now we haven't sorted a single element, so it will always point to the first element. Okay. Now we will simply swap the positions of the minimum element with the first element. So here we can see that 11 has taken its correct position, which is the first element, and all other elements are simply at their position with 64 swapped. Okay, just a second. Okay. So that 11 is at its correct position. We'll now find the next smallest element. Now we'll exclude 11 as it is at its correct position. Okay, so we will find the next smallest element, which will be 12 now, because 11 is already sorted. Now 12 will be swapped with the second index, which is 25. So now 12 is also occupied its correct position. We will also exclude it from our comparison thing. We will move on from third index, from second index onward, which is 25, 22, and 64. Now again, we will find the smallest element, which is 22 among these. We will also swap it to the position, which is next position is the second index. 22 also occupied its correct position, and we will keep on repeating the last element 25, which is smallest. It is already at its correct position. We don't need to swap it. Then we will move the last element where the minimum element and the current element is same, so we don't need to swap it. So in this way, we have sorted the complete array. Okay. So is the approach clear to everyone? What we are doing over here? If anyone has doubt, you can ask.
अभी तक सॉरी आई हैड जॉइंड लेट अभी तक कितने सॉर्टिंग हुए
ये
मतलब सर्चिंग
sorting का first ही example है. You can
और
continue
सर्चिंग
from.
हुआ था इसके पहले
No. Searching will be taken in the next lecture. We are doing sorting today only.
ओके थैंक यू
Okay. So we will see the code, how it is coded now. Okay. So here's the code. We have simply defined the vector containing elements 64, 25, 12, 22, and 11. The similar example that we have explained in the diagram. Okay. So here's the selection sort function, which we have defined. We have passed the vector. Do you know what is this AND ARR? Why we have used the AND operator?
रेफरेंस
Reference.
Yeah. So basically, there are two kind of ways in which we can pass any argument, which is passed by value and passed by reference. So whenever we are passing by value, if we would have passed it by value, what would have happened is that another copy of the array would have been created, and whatever changes we made would have been implemented in that copy. But now that we are passing it by reference, whatever the changes we make over here will directly be done into the array that we are passing. No copy of it will be created. So this is the difference between pass by value and pass by reference. Okay. So let's see how we implement the selection sort. Okay. So simply we are traversing from start index to the end index. Okay. Uh, the minimum index, we have assumed that the first element holds the minimum index currently. As the loop goes on, each and every element will be placed at its correct position. So simply the current index will move on from 0, 1, 2, as we have seen in the diagram. When first element is placed at its correct position, the array size is decreased by 1, or the starting position is incremented by 1. So similar thing is getting implemented as we are looping over here from 0 to n minus 1. First the min index will be 0, then 1, because we can simply swap the elements with the. Okay, what doubt you have, Shreyansh? Okay. So the min index is simply representing the index at which we will swap the smallest element to. Like in the diagram, uh, what the current element we have written over here is what we are defining as the min index in the code. Okay, so the min index will be 0, then 1, and so on. It will just progressive. It will just progress according to the index of the loop. Okay, the min index over here is 0 at first. Okay, now we are iterating through the unsorted position because we need to find the minimum element to swap. So we are simply traversing from the next position because we have assumed that the first position has the minimum number. So we'll just iterate from the next position I plus 1 till the end of the index. Now we have compared each and every element with the min index, and if we find an element which is smaller than it, we'll simply give the index of that element to the min index, just implying that it is the minimum element which we have found, or the smallest element which we have found. Okay. Next step is move the minimum element to its correct position. Now to move the element to its correct position, we have found the index of the smallest element, and we know that no element has been assigned till now, so it will be the zeroth index, that is the first position. So we simply swap the elements at the zeroth index with the element at the min index. Okay, so this will simply place the first smallest element at its correct position. Now similar thing has to be repeated again and again till the complete array has been sorted. Okay, as we have seen in the diagram, we are just swapping elements one by one to their smallest positions, and in that way the complete array is being sorted. Okay, so in this way we will simply get the sorted array by swapping the elements. Either we can use the smallest swapping or largest swapping. If we would have used the largest swapping, instead of swapping at the first position, we would have swapped it with the last position. So the traversal would have been from the last position, that is n minus 1 to 0. Okay, everything else will be similar. You can just see the code once, and if you have any doubt, ask. Okay, just go through the code once, and you have any doubt, you can just ask. Also think about the time and space complexity of it.
O of n square time complexity and space would be O of 1, right?
Yeah. So everyone is clear with the code. If you have still any doubt, you can ask it. Don't hesitate to ask any doubt, because these are initial lectures. So there's no need to hesitate in it. Okay, great. So as he said, the time complexity of O of n square and a space complexity of O of 1. Okay. O of n squares, the time complexity is O of n square simply because we are using a nested for loop over here. We are using a for loop to traverse and another for loop to find the minimum element. So it will simply be of, okay, Manavaditya.
How will the space complexity be O of 1? Won't it be O of n?
Now look, we have defined the array earlier and we are just making changes in the array. That's what we are doing. We are not using or defining any other array to do the sorting. If we would have defined another array and then we would have put these elements in it using some kind of operation, then the space complexity would have been increased. But we are only using the same array and just swapping the elements. That's why the space complexity won't increase.
Okay, fine. Thank you.
Okay. So let's see the next algorithm. Okay, so bubble sort. Bubble sort is similarly, we will also swap over here, but what is the difference over here? Let's see. Okay. We will swap here repeatedly, similar to what we have done earlier. And this algorithm is not suitable for large data set because the number of swaps that we are performing are comparatively higher as compared to the previous algorithm that we have seen. Okay, that's why if you have a large data set, we don't use bubble sort. It also depends on the use case, but it's a general thing. Okay, let's see the steps that we follow. So we have to sort there using multiple passes. After the first pass, the maximum element goes to the end. And the similar way, after second pass, the second largest element will go to the end. Now in the previous example, we have put the smallest elements at its position. Here we are using putting the largest element. Similarly, you can also put the smallest element over here, but to just give it a different taste of it, we are using a largest element over here. Okay. So in every pass, what we will do is simply compare two elements with each other. And if we find that the element which is at a lower index is lesser in value to the element that is at higher index, we simply swap them. So this swapping would simply uh, put the element in larger value to a larger index, and by performing it repetitively, the largest element will simply get its position, which is the last position. Okay, so this will be done in multiple passes. So in a single pass, the largest element will occupy its position. In the next pass, the second largest will occupy its position. And similarly, till we have only single element left. Okay, let's see in it. We have 5 and 1. So 5 is lesser than 1. We will swap it. 1, 5. Then comparing with 5 and 3. 5 is less than 3. We will again swap, and we have known that 6 5 and 6 will be compared, but as 5 is lesser than 6, so no swapping will be done. Okay, so two elements have been placed in that position. Again, we will compare 1 and 3. 1 is lesser than 3, so no need to swap. This way the array has been sorted. So is it clear to everyone? We are simply comparing two elements over here and swapping them with each other. Earlier, what we did was we used to traverse the complete array and find the smallest element and swap it at its position. But here we are what we are doing is simply swapping it, and taking it to its correct position. Just look at the step once and ask if you have any doubt. Then we'll see the code. Any doubts? Okay, let's see the code. So this is the array that we are performing bubble sort on. This is the sorting function. Okay. Now, for now, just ignore the boolean which we have defined over here, bool swapped. Just focus on what we are doing. Okay. The outer for loop for the traversal, because we have to put each and every element at its correct position. So we are using a outer for loop. Now in the inner for loop, we are performing the comparisons. Here we have compared the element in the jth index with the element at a higher index. Now, if we find that the element at the lower index is larger in value than the element at higher index, we are simply swapping them with each other. So this will put the larger element at a higher index, and this operation will be performed throughout because we are comparing it with each and every element. So the largest element will simply occupy its position. In this way, a single element has been put to its position. Then again, we will begin with the next element. We will put it at its correct position. Similar way, as we perform the passes, the largest elements will occupy their correct position, and the array will be sorted. Now, what's the reason of defining the boolean over here?
To break out if it is already sorted. That way it's O of n in the best case.
Yeah. Just look at the code and what he said and think for it. What the boolean over here is doing is that if we see that no swap over here is occurring, okay, so what it will mean is that the array has been sorted, or whatever the array that has been left to be sorted is already sorted, so we don't need to perform the operations again and again. So we just define a boolean which is defined to true whenever we are entering this if condition. Now, if we don't enter this if condition, simply the swapped boolean will give us an idea that the array is already been sorted. So if it is sorted, we don't need to swap any elements. We will simply break out of the loop. This will just reduce our time complexity in case that the elements are already sorted. Okay. Again, think of the time and space complexity. Just given in chat, don't speak on. Okay. Write it in the chat. Okay. Time and space complexity instead of speaking so that everyone can think of it. Just write n square n. That's fine. Okay, n square. Right. What about the space complexity? Yeah, O of 1. Yeah. So as we haven't used any further array or any other element to perform the sorting, the space complexity will simply be of 1. And as we are using nested loop, it will be n square. Time complexity will be n square. Everyone is clear with this? Okay, great. So we'll move on to the next, which is insertion sort. Now, insertion sort is simply what we are doing is iteratively inserting element of an unsorted list into its correct position in a sorted list. Okay, we can think of it as we are dividing the array into two parts. One part is sorted and other part is unsorted, and we are just putting the unsorted element at its correct position in the sorted array. So, what are the steps? We start with the second element of the array, as we always assume that the first element is at its correct position. Okay, now we will compare the second element with the first element and check if the second element is smaller. If it is smaller, then we will swap it. Then we will move to the third element, compare it with the second element first. If it's smaller, then we will have to swap it. Then we will compare that element with the first element again, and if it is smaller, then we have to again swap it. Okay, then we move on to the third element and do the similar thing. Let's look at the diagram for a great understanding of it. Here we have assumed that the element 23 is already at its correct position. We perform the first pass. We are comparing the second element to the first element. We find that the second element is smaller, so we will swap it. Then we will move on to the next element, which is 10. Now 10 will be compared with both the second element and the first element. So first we compare 10 and 23. We find 10 is smaller than 23. We swap. Then we again compare 10 and 1, but 10 is greater than 1, so no need to swap it. Okay, these way three elements have been put in their position. Then we go on to the third pass. We compare 5 with both the first, second, third. So 5 and 23, 5 is smaller, it will swap. Again, 5 and 10, 5 is smaller, it will swap. So 5 will occupy its correct position at second place. And the last element 2, again similarly we have to compare it with each and every element. 2 and 23 we will swap it, 10 23 we will swap it, 5 2 we will again swap it. So 2 will occupy the position at second. So in this way we are putting each and every element at its correct position by swapping it with the earlier elements. We are just comparing it with each and every element at its beginning, and if it is smaller we are swapping it. Now we have arranged here by using the smallest element swap, we can also perform a largest element swap in a similar way. So is everyone clear with the approach? Okay, great. Let's see the code. So here's our insertion sort function. We have first defined the key starting from the first element, as we have assumed that the element at the 0th index will already be at its correct position. And then we are defining j, which is I minus 1, simply because we have to compare the element which we have currently put in key with each and every element previous to it. So we have defined j as I minus 1. Now we will traverse, like we have to compare with each and every element previous to the key element. So we will just go on from j is equal to 0, j greater than equal to 0 till j is greater than the jth element is greater than q. Here what we are simply doing over here is we are comparing our key element with each and every element previous to it. Okay, so I minus 1 till 0, we will go on comparing the key element with each and every element, and whenever we find that our key element is smaller, we will swap it with the jth element. In this way, the swaps will be performed and the first element will occupy its correct position. Now the key element will be shifted to the second element of an array. A similar operation will be performed. And then the third element, the similar operation will be performed, and in this way each and every element will occupy its correct position. As we are progressing in the array, the number of comparisons are increasing, as we have to compare it with more and more elements. Okay, so algo is comparatively simple. Just look at the code, think of time and space complexity, and if you have any doubt in it, ask. Is everyone clear? If you haven't understood anything, you can ask. Okay, best cases, yeah. It will be O of n. If the array is already sorted, you will have to just compare it with the previous element. You will see that it is already like if you have an array 1, 2, 3, 4, 5, and you are performing an insertion sort. So we will begin with the second element. You will compare 2 and 1. You will see that uh, 1 is already smaller than 2, so it will not be swapped. You will move on to the next element, which will be 3. We'll compare 3 with 2. Now 2 is already smaller, you don't need to swap. In this way, you just have to do a single pass, and as the comparison is not being done with each and every element, that is as it is breaking in a single element, the time complexity will be O of n. Yeah. The best case in all the sorting techniques is that the array is already sorted. But in all the algos we have seen, we have to perform a single pass to verify if it is sorted or not. So in the best case, the time complexity will be O of n. Is everyone clear? Okay. Now let's see some questions. So here's a question on reversing an array. You have been given an array and you have to reverse the array. Okay. Now think of the approaches that you can use. Here's an example. We have the array 1, 4, 3, 2, 6, 5, and you have reversed it to 5, 6, 2, 3, 4, 1. Okay, 2 pointers. Think of the naive approach, brute force approach. It's okay. We have not learned about pointers and all. So if you are getting naive approach any, you can also think of it. Yeah, swapping the first and last element and doing it repetitively. Yes, we can also travel from 0 to size by 2 and then swap them. Yeah, swap index of equal distances. So you know about it, but we will not touch upon the pointers approach, as I didn't knew you knew about pointers. We will see that approach in the later half. In the next lecture, I will include that approaches and explain it to you. But in this, we'll just see the brute force approach, which is by making a new array. Okay. So this is the code. What we are doing over here is creating a temporary array and just simply traversing. While traversing, what we are doing is assigning the first element of our temporary array with the last element of the array. In this way, it will repetitively assign the values from the last to the first element of the array that we need to swap. For example, in the array 1, 4, 3, 2, 6, 5, we have the first element of the temporary array will be assigned the value 5. The next will be assigned the value 6, and so on. So in this way, it is being reversed simply. I don't have the code for two pointer in it because I thought you didn't know about it, but I will just explain it to you, the other approaches that you have put in the chat. Another approach is swapping the elements. Like we have array 1, 4, 3, 2, 6, 5. We will simply have a pointer pointing to the first element and a pointer pointing to the last element. And in each cycle, what we will do is simply swap the element which is at the first pointer with the element which is at the last pointer. So in this way, the array will become 5, 4, 3, 2, 6, and then 1. Now the pointer will be incremented. So the first pointer will be pointing to 4 and the last pointer will be pointing to 6. Again, we will swap these elements. So the array will become 5, 6, 3, 2, 4, and 1. Then again, we increment the first pointer to 3. The last pointer is decremented to 2. And again, the swapping is performed. Now the condition to stop is whenever we see that our first pointer is exceeding our last pointer, we stop. Okay, so this is the swapping approach. I will include the code in the next class and explain it to you. Even if you don't get it, it's okay. We'll just see another question before we end the lecture, which is finding the second smallest and second largest element in an array. The problem is that you have been given an array and you have to find the second smallest and the second largest element in the array. And if they are not present, you simply have to print -1. For example, the array over here is 1, 2, 4, 7, 7, 5. So we can see the smallest element is 1, the second smallest element 2. The largest element over here is 7, the second largest is 5. So we have to print 2 and 5 over here. Another example where the size of array is 1. So 1 will be the minimum element and 1 will be the largest element. So there are no second smallest or second largest. So we simply print -1 in both cases. Have you understood the question? Okay, think of approaches and you can put your approach in messages. Yeah, we can sort them. Okay, you are getting the sorting approach. Yes, sorting and then yes. Okay, so let's see the first approach, which is sorting, which you all have suggested. Now the approach is great. It's simple that you simply sort the array by using any of the methods we have seen, and you will print the second last element and the second element of the array, which will be the smallest and largest element. But the issue with this will be if we have duplicates in the array. If we have an array which is 1, 2, 2, 3, 4, 4, 5, so it is sorted. But if you see that the last element and the second last element are same, in that case we will not get the second smallest element. Okay, so if we would have an array like 1, 2, 2, 3, 3, and if we return the second largest element as the last second element, we are not getting the second smallest element. Okay, so this is a drawback of this approach. But if we do not have any duplicates, we can use this approach. Okay, so what's the approach is sort the array in ascending order. The element present at the second index will be the smallest one, and the element present at the second last will be the second largest element. Here's the code. The code is pretty simple. You're using inbuilt sort function. Okay, as we have used array, so we are simply defining inbuilt sort function arr and arr plus the size of the array. Once the array is sorted, the smallest element will be the element at the first index and the second last index. Now that this approach has a drawback, what other approach can you think of? Think of an array with duplicate elements and what will happen in that case. Don't worry about the time or space complexity, just think of solving the problem. Yes, we can use passes. Okay, so let's see the approach which you all have been thinking of, which is by using two passes. Okay, so what this approach is, simply we will traverse the array first, finding the largest element as well as the smallest element in the array. Then we will again traverse the array. Now that we know the smallest element and largest element, what we will do is that we will compare every element with the second smallest element that we need to find. If it is small, we will simply assign the value of that index to the second small. But we will also check at the same time that the element that we are putting a second small is not equal to our smallest element, because you want to find the second smallest element. So in this way, we will first find the smallest and the largest element, and then while again finding the second smallest, we just add a thing that the element that we are putting in as the second smallest is not equal to the smallest element. So we'll simply get the second and smallest and the second largest element. Is everyone clear with this approach? Okay, great. Can you think of more optimized approach, the best solution to this problem? Think of this time and space complexity that we are incurring over here. Yeah, the time complexity is O of n and the space complexity is O of 1. Okay. So there's another approach to it, which is the best approach. Just think of it. Yeah, if you are creating a new array just to remove duplicates, that would just be more costlier. You can use set in place of it. Yeah, we can define two variables, smallest, second smallest, and when we are traversing, we can assign values to both of them. Yes. Yeah, you can copy distinct elements by creating a new array, but that will increase the space complexity. Currently, we don't have any space complexity. We are doing it in constant space. Okay, that's another approach, but that will incur you space complexity of O of n. Okay, so let's see the best approach to this problem. Here we are defining smallest and the second smallest element. We are assigning it the value of int max. So firstly, we are traversing to find the second smallest element. What we'll simply do is that we will compare each and every element of the array with the smallest current element. And if we find that the element is smaller than the current smallest element, we will assign that element to the smallest element, and whatever will be the value of the smallest element will be given to the second smallest element, because now we have found out an element which is smaller than the earlier smallest element. So what we are simply doing is that every time that we found that there is a smaller element than whatever the smallest element we have allotted already, we are doing this step, which is assigning the smallest element to the second smallest one and assigning the now found value to the smallest one. In this way, in a single pass, we can find the second smallest element. And another thing is that we'll compare if array element is less than the second smallest element. In this case, we are simply updating the second smallest element. Okay, this is the similar thing that we have implemented earlier. We check if it is not equal to the smallest element, and simply we are assigning it the smallest value. So by this you will get the second smallest element in a single pass. Okay, so the n square time complexity will not be incurred. Similarly, you can find the second largest element. Here we will compare the array element to the largest value. If we find that the array element has a greater value, we will do the same thing. We will assign the largest value to the second largest one and assign the now found value to the largest element. Similarly, the largest element will be assigned. Now, if we find any element which is greater than the second largest element but not greater than largest element, in that case we only update the second largest element. In this way, we'll get the second largest element in a single pass. Is this approach clear? Okay, so that's all for today's lecture. If you have any doubt, you can ask.
Is it necessary to like get very familiar with the code of the sorting algorithms?
Sorry, can you repeat? Sarang, can you repeat?
Hello.
Yeah.
Yeah, is it necessary to get very familiar with the code of these sorting algorithms, or are they inbuilt?
We have inbuilt functions and we will generally use inbuilt functions whenever we are coding, but it's necessary to know all of this because maybe there might be applications where we will come to use it, and whenever you will give interviews for your jobs or internships, they ask these algorithms, so you should just keep in mind what's the approach of it. Once you know the approach, you will be pro. Till then you can easily write the code given you know the approach. To just know what we do in bubble sort, what's the difference between them. We are simply swapping and assigning the correct position of element in each case. Just one thing you have to keep in mind is what's the difference in the approaches in all the three cases. Just keeping in mind the approach is okay. You don't need to learn the code, you will anyway write it. Whenever coding, you can simply use the sort like predefined you have, but just keep in mind what are the approaches. It's also part of our syllabus and they also ask it in interviews, so you should know the approaches. Any other doubt? Okay, so you will be given assignment maybe till tonight only. You have to solve it and post it on the classroom. Now, if you want to really learn, please don't use any AI tools. I know we all are pro in that. We have also done that. Every one of us does that because we are in the new era and we have to use it. But please don't use AI to write these codes. If you have any doubt, you can just comment in the classroom. We will solve your doubts. In this way, you will get a better understanding of the topic and you will remember it for a longer time. The more doubts you have, you will remember it for a more longer time. So if you have any doubts, post on the classroom. We will resolve it and try to write the code by yourself to the questions, whichever questions you've been given in the assignment. Because there's no marking on how good you solve it without any doubt. Okay, you have to learn it. So ask if you have any doubt and solve it on your own. If you find there's any chat GPT or any copy in the code, we will deduct marks for it. But more marks are okay, but you should learn. So you should just post whatever doubts you have and we will solve them. But try to solve the problems on your own, okay? Yeah, so that's all from today. I hope you have understood this topic. In the next class, we will see the searching algorithms, linear and binary search, and we will also solve problems based on them.
Merge sort won't be covered.
We have not yet touched the topic of recursion, so that will be taken later once recursion is done, so you can take a better understanding of it.
Oh, okay.
Okay. In the next class, we will see the searching linear as well as binary search, and we will solve more problems, interesting ones. Okay. So everyone do the assignment which will be given in the classroom. That's all from today. Bye.